I mean like the graph, sorry. What does the graph of an exponential function look like? No one knows? It's one of those that goes like slow, 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 and then like just shoots up, or slow, 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 and then shoots down real fast. So like when people say something grows exponentially, it's like it doubles and then it like all of a sudden, just it compounds on itself. It gets much bigger or much smaller very quickly. So we're going to talk about this type of function a lot in the next several days. That's the first blank here is just the basic form of an exponential function. So a times b to the x power. And we're going to talk about what some of these details mean for it. So it says here, if b is greater than 1. Okay, so here's your b. Basically, we're saying if the number that has the exponent attached to it, that will always be the b value. The a value will be something different. But if your b has a number greater than 1, is a number greater than 1, we call this an exponential growth problem. Okay, so it is growing exponentially and is increasing. Okay, it's on its way up. If we're going from left to right, it's going up from left to right. Okay. The second part here says if 0 is less than b is less than 1. So it's not just that b is less than 1. We don't want to get into the negatives, but if it's a number between 0 and 1. So tell me what a number between 0 and 1 look like?
0.4.
0.4, which would be 4/10 or 2/5. Give me another number between 0 and 1. Any number between 0 and 1. How about 1/2? Is that a number between 0 and 1? Can you give me another number between 0 and 1? What? 0.1, 1/10. Okay. So a number between 0 and 1 is a fraction or a decimal, but those decimals represent fractions. Okay. So basically what they're saying is if your b value, if this number represents a fraction, then this is going to be an exponential decay setup, and it is decreasing. Okay, so you want to look at this number. The number that has the exponent attached to it is going to tell you a lot about a problem. If that number is a fraction between 0 and 1, it's going to be, I got to think about this backwards now. For you guys, it would be going something like this. Like the numbers go and then all of a sudden they drop off. That's moving left to right for you, right? Yes. Whereas an exponential growth, if that number is more than 1, it's going to look like this, right? So it's going to be moving left to right and then all of a sudden it shoots up, okay? So exponential growth versus exponential decay. There is something called an asymptote. Have you heard that word before? Asymptote? Acetone? Different, but yes, they sound similar. An asymptote is a line that shows up a lot in math. It is a line which the graph gets closer to or gets close to, but never touches. Okay, so there's going to be this line that's kind of your like cutoff point. Like we're never going to actually touch that line. It's always getting closer and closer and closer and closer and closer to it, but it will never touch it no matter how far you go, which is kind of hard to wrap your brain around if the number is constantly decreasing, decreasing. But it really does never touch that line. Okay, so that's called an asymptote. Okay. So we're going to take a look at just these first 3 problems, okay? One thing that you're going to do, and on your quizzes and like the review homework, I did this part for you, but in the normal homework, they never do. Sorry. I should have just added it in, but I didn't. You're going to make a T-chart in all of these. So go ahead and set up a little chart like that, X and Y. You want 5 blanks. Sometimes you'll do a 6th or a 7th, depending on what your numbers are looking like. But you always want at least 5 points here. And the beautiful thing is you're always going to do the same 5 numbers unless you need to go beyond those 5 numbers, okay? So the numbers you're always going to plug in will be -2, -1, 0, 1, and 2. Okay, so here's what I want you to look at. The equation that we're going to graph right now looks like this. Now, think back to what we set up here. Okay, if b is greater than 1 versus if b is some number between 0 and 1. Looking at this equation, y equals 2 to the x power, do you think this is exponential growth or exponential decay? Growth. Why is it growth? A fraction's positive too. Greater than 1, okay? So we have a number greater than 1 here. That means this is going to be a growth problem, okay? So you shouldn't have to graph it to see that. You should be able to see that just looking at the equation. Now, here's why it's wonderful that you can graph or that you can see it just looking at it, because then when you go to graph it, if your graph does something different, you made a mistake, okay? So check it first against what we think it should be because of this number. We think it should be a growth problem. But then graph it and see, is it looking like growth? From left to right, are you on your way up? So if I'm going to plug in a -2, a -1, a 0, a 1, and a 2, you are welcome to use your calculator on this. Would I love for you to do some mental math here and remember your rules of exponents? Absolutely. But am I going to force you to? No. So what we're going to do is we're going to plug a -2 in for x. So it's going to be 2 to the -2nd power. Get your calculator out. David, what are you drawing right now? Is that like a horse? Don't know. Okay. All right. So if you plug this into your calculator, 2 to the -2nd power, what does your calculator tell you right now?
Error.
Really?
Yeah.
It shouldn't. Did you do -2 or -2? The negative button. So you're going to go 2 and then hit this little caret button and then the negative, not the minus,
Yeah.
and then 2. Bring it here.
Syntax error.
Negative is, oh, let me see which calculator you have. Next to the decimal point on the bottom. That one. Oh, well, you've got all kinds of weird things going on there. Look at all those decimal points. Let's just do this. Okay, 2 to the negative. You did this one. Second. I cleared it. You had a funky setting. What do you get? 0.25. Okay, so if you like decimals, you're welcome to do that. Here's what I would love if you saw. Anything to a negative power, we can do what with? What does that negative exponent do? Moves it down, right? So I could call this 1/2 to the 2nd power, which is 1/4. Or you could just take what you put in your calculator and turn it into a fraction, and it would be 1/4. I love this. She, the girl that wrote this curriculum, always does decimals. So if you want to leave it as a decimal and you understand where a decimal goes when you graph it, great. I'm totally fine with that. I just think, what a beautiful thing to get to use the properties that you just learned, right? Right. Okay, so if you do 0.25, that's fine. If you do 1/4, that's fine, okay? I'm going to give you both answers each time. Plug in the -1. 2 to the -1st power. What do you get? 0.5, or you could do 1/2, okay? If you plug in 2 to the 0 power, what is anything to the 0 power? 1, always 1. Plug in 2 to the first power, you get 2, and plug in 2 to the second power, you get 4. Okay, so now you're going to take those points and you're going to graph them. So -2, that would be over to the left 2, but then your y value is 0.25 or 1/4 of the way up to 1. So you're not even going to 1, you're going a quarter of the way. So like right there. Okay, just a quarter of the way up.
If we don't get it exactly.
Now I'm not gonna, it just generally speaking, yeah. Your next one, -1, and then 0.5 or 1/2. That would be right here. Okay, your next one, 0, 1 is right there. Your next one, 1, 2. So 1 to the right and 2 up is right there. And then the last one, 2 to the right, 1, 2, 3, 4 up is right there. So you have these as your points. Okay, 5 points. Can you kind of see what they're doing? Like if we followed that general curve, where does it look like our asymptote, the line that we're never actually going to touch might be? At 0. It's the x-axis. Yeah, this is where your asymptote would fall. Okay, this is the line that we would never actually touch. So your graph ends up looking, and God bless you if you can do this well. I suck at this. I just do. So mine always ends up not looking beautiful. But you're going to draw a line and just kind of follow that curve. There should be an arrow on both ends because it keeps going in both directions. Okay, but your graph looks something like that. Okay, now let's talk domain and range. Do you remember what domain represents? It's not the y, it's the other one. It's the x. So your domain is always the x's, your range is always the y's. Or you can say x and y just to help you remember that. So basically we're saying, what can you plug in for x values? Well, notice this arrow goes forever to the left. So it's going to go to every x value. Your left is this way, huh? Every x value to the left. This arrow keeps going. And while it doesn't go as quickly to the right, it goes forever to the right. So you could plug any value in for x to the right of where we're at here, which means you could really plug any value you want in for x. I could plug 1,000,000 in. I could plug in -25, I could plug in 0, I can plug in 13, okay? So your domain on every single one of these will be all real numbers. Remember that one? We did the R. So it's the double with the R, or you may write all real numbers. Okay, but if you want to write the R, that's fine. Okay, so the domain on every single one of these problems, free point for you, is always all real numbers because you can plug anything in for x. You cannot, however, get anything for y. Let's think about that. If you look at this picture, where's our asymptote? What y value? What y value is this line through? 0, okay? So what we said about an asymptote is we will never hit that number, which means every y value that we graph has to be above or below that line? Above, right? Because our graph right now is above that line. So for the range, you're going to say your y value has to be greater than wherever that asymptote falls. So in this case, your y value has to be greater than 0. You will never have a y value anywhere on this graph that is below 0. What's a y-intercept? Where it hits on the y-axis. So here's my y-axis, okay? What's my y-intercept right now? 1, 0, 1. The point 0, 1 is my y-intercept. Now here's the deal. You're plugging all of these numbers in every time. It's always the one that's the 0, right? When you plug in 0, what do you get? Your x value is 0, your y value is 1. So this will always be your y-intercept, whatever 0 something is, okay? And then the asymptote, the equation for the asymptote is really easy if you've already found your range. It is going to be the exact equation of your range, but with an equal sign instead of the greater than. Because your asymptote is what you'll never hit, which means your range is everything above or below that. Okay? So instead of saying y is greater than 0, now it's y equals 0 is that blue line that we're looking at. Questions on that?
So your domain is just going to be
All real numbers every time, because you can plug anything in for x. Okay? Okay, let's do the second one together. Actually, no. No. I'm going to have you try the second one yourself, and then we'll do the third one together. You may chat with your neighbors about it if you're not sure what you're getting. I will help get you started here. You're going to do a T-chart, x and y. What numbers are you going to plug in? -2, -1, 0, 1, and 2. So you are plugging into your calculator. You should use parentheses if you're going to go 1 divided by 4. If you're going to use the fraction button, I don't think you'll have to. But basically what you're doing right now is 1/4 to the -2nd power. That's what you'll put right here. So do those 5, plot where they would go. Tell me, is that an exponential growth or decay? What's the domain? What's the range? All of it. Just makes it a fraction, right? Just flips it. So because it was already a fraction, even if it flips it, now it's over 1 instead. Interesting. Flip this in, so 1/4 to the -2nd. Okay, so go. Do you like to use the fraction button or the division sign? Like 1/4. Show her, just plug 1/4 into your calculator right now. Okay. I think if you're going to do it that way, then you have to put parentheses around it. Let's just double check. Yeah, so 1/4 to the -2nd, so that's 16. So this will be 16, and then we just keep doing. Yeah. So if one of them falls way off, if it's just the one, don't worry about it. You don't need to graph it. If a lot of them are, then you want to pick numbers beyond it the other way that you can plot. But if it's just one, like that -6 or 16 falls way off, you don't need to graph the 16. You can just leave it. What?
What was the -16?
It was positive. I said negative, but yeah, positive 16.
It's 64, 1, 0.25.
Yeah. How do you plot it? Do you like it better as a decimal? Does it make more sense as a decimal to you? Like where you would plot it? So the point is
0.062.
right. So you can do it however you want, but think about what 1/16 is. Basically what we're saying is, so if you're at 2, but then you're only 1/16 of the way up to 1, right? Think of from here to here, there's 16 little marks. So it's going to be really close to the line.
Okay. I got 0.06.
You can write that. Yeah. Okay, let's take a look. Did you determine this is growth or decay?
Decay.
This is decay. You should have been able to tell that right here already, because that number is between 0 and 1. It's a fraction, okay? So if it's between 0 and 1, then it would. Question, what if it was this? Is that decay? Because it's greater than 1. It's a fraction, but it's 1.5, right? So that's not decay. This would be growth. Okay, so you plug this in 1/4 to the negative second power, and you get what? 16. Then you plug in 1/4 to the negative first power, and you get what? 4. 1/4 to the 0 power? 1. 1/4 to the first power is 1/4 or 0.25 if you like the decimal. 1/4 to the second power? 0.0625, was it? Okay, so either one of those, okay, the decimal or the fraction. When you go to graph that, this is the one that goes way off the page because this only goes up to 10. So you would be like way up here somewhere. Just don't graph it, okay? Leave it off. -1, 4. So 1 to the left, 1, 2, 3, 4 up. 0, 1. 1, and then 1/4. So 1/4 of the way up to 1 would be about there. And then 2 1/16. That's even closer. Okay, which is pretty hard to represent, but do your best. Where does it look like your asymptote is right now? At 0. So this would be your asymptote. Your graph looks like this. Okay, we already said that's decay. It's on its way down when you're moving from left to right. What's the domain? Always. All real numbers. So you can do that, or you may write all real numbers. What's your range on this one? Not less than 0. Greater than 0, right? It's above the x-axis, so y is greater than 0. Where is your y-intercept right now? At 0 again. Or is at 1 again. 0, 1, sorry. It's at 0, but what your y value is, this will always be your y-intercept. When you plug a 0 in, what do you get? So your y-intercept is 0, 1, okay? And then your asymptote, remember, it's always this, just with an equal sign. It's your range with an equal sign. So that line, this green line right here, is the line y equals 0, because your y value, no matter where you go there, is 0. Okay? Okay, here's what I want you to see. This was y equals 2 to the x. This is y equals 1/4 to the x. Okay? This one is 3 to the x minus 1. So now there's a new element coming into play here. So we're going to figure out what those numbers are. Remember, you plug in your x and y. So -2, -1, 0, 1, and 2. And again, your calculator will do this for you. So you plug in 3 to the negative second minus 1. What do you get? It's a goofy one. It's okay if you got a goofy number. What is it? It should be a negative 0 point, what? 8 repeating. So you may either write it like that, or you may hit fraction, right? The S to D button, turn it into a fraction. It's -8/9. I like fractions better. I see it better when I do it as a fraction. If you want the decimal, that's fine. So then the next one, 3 to the negative first minus 1. Plug that in. What do you get? -2/3 or -0.6 repeating. Okay, so either one of those, you may call it either one. 3 to the 0 power minus 1. What do you get there? What? You get a 0 out of it because this equals 1, right? 1 minus 1 is 0. 3 to the first minus 1. What'd you get? 2. And then 3 to the second minus 1 should be 8. Okay, so now you plot these points. So take a look at what happened with this one. This one's going to look a little bit different. -2, -0.8 repeating. That's going to be really close to -1, but not get to -1. Okay, -1 is -2/3, so that'd be about there. 0, 0. 1, 2, and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. What do you notice that's different about this graph from the previous two?
It's under the y-axis.
It's under the y-axis now, okay? What do you notice about the equation that's different?
There's no fraction.
This went to the y-axis. This went to the y-axis. This went below the y-axis.
Because there's a -1.
Because there's a -1, right? It's shifting the whole thing down 1, okay? So just keep that in mind. That's how this looks. So you would have, oh, see, that's me being terrible at this. You would have that. Your asymptote is actually that -1. So the asymptote is here, which I did not draw well. My line is a little too thick. So tell me the things, growth or decay? Growth. It is on its way up from left to right, and the number that's taken to the power is greater than 1. Okay, so that's exponential growth. What's your domain? All real numbers. Good. What's your range? This is different. Your y value is what?
Less 0.
What's your lowest y value?
Greater than negative.
Greater than -1, right? This line right here is at -1. It's got to be above that -1. So y is greater than -1. What's your y-intercept? Where did we hit the y-axis? At 0. So your y-intercept is 0, 0. Like I said, it will always be that 0 whatever. And then your asymptote, what should that be? Y equals -1. So these two will always be the same, but the range will be an inequality. The asymptote will be the equation for that inequality. How'd we do?